Hello, I'm Miles Tails per hour. We will learn about sound waves. As before, we discussed about standing waves. We also use two tuning forks to determine beats. A sound wave is a pressure wave, regions of high pressure, called compressions, and low pressure, called rarefactions, that are established as the result of the vibrations of the sound source. These compressions and rarefactions result because sound is more dense than air and thus has more inertia, causing the bunching up of sound. In human physiology and psychology, sound is the reception of such waves and their perception by the brain. The audio frequency ranges from 20 Hz to 20 kHz. In air at atmospheric pressure, these represent sound waves with wavelengths of 17 meters to 1.7 centimeters. Sound waves above 20 kHz are known as ultrasound and are not audible to humans. Sound waves below 20 Hz are known as infrasound. Also, different animal species have varying hearing ranges, that is above 20 kHz. For example, dogs can hear more than 20 kHz. Although sound can propagate through a medium such as air, water and solids as longitudinal waves and also as a transverse wave in solids. You know, echo formation forms when you clap with hands. Sound waves can hit from wall to wall, causes reverberation, especially in large rooms, such as a big hall. Note that the speed of sound is given by 340 meters per second. But actually, some other physicists or mathematicians measure value 330, or 333. This is a slight error in approximation, as a difference of 7 to 10 meters per second. The speed of sound depends on the medium the waves pass through, and is a fundamental property of the material. The first significant effort towards measurement of the speed of sound was made by Isaac Newton. Then he believed that the speed of sound in a particular substance was equal to the square root of the pressure acting on it divided by its density. He denotes it as C. This was later proven wrong when found to incorrectly derive the speed. Soon, the French mathematician Laplace corrected the formula by deducing that the phenomenon of sound traveling is not isothermal, as believed by Newton, but adiabatic. He added another variable gamma to multiple by pressure per unit density and the square root. Then finally transformed into Newton-Laplace equation, equal to square root k over rho, where k denotes as a bulk modulus equal to gamma multiplied by p. We can therefore generate sound waves using loudspeaker. At the calibration of pitch 440 Hz, it can be either sine wave, square wave, triangular wave, or sawtooth. In sine wave form, in square wave form, in triangular wave form, and in sawtooth form. Let's try another frequency pattern. For example, making multiple frequency of 100. Why the tone remains the same as we multiply by 2? Because the wavelength will decrease by ratio of multiple 2. As 440 Hz was marked, it was named an A key. Makes the scale from C to B, it was used in some kind of musical instruments. The C note was marked as the starting point and B note was marked at the last. The C note is marked as 520 Hz and can be played. That is upper C key. The middle key is half times the upper key, which is 260 Hz. From least to highest, how far can you hear the pitch? Starting from 33 Hz, and multiplying by 2. This is the first key C. The hearing sound suddenly decreases as we reach the ninth C note. That is 8.32 kHz. This can be depicted as a table of frequency, which is called octaves. So, I hope you now know how the sound waves work. Like, comment, and subscribe now.